Hello and welcome to the NXP Semiconductors and Future Electronics webinar on Unleashing Your Smart Devices with i.MX RT. We have two fantastic experts on the call, Matt Wasson from Future Electronics and Eduardo Montanez from NXP Semiconductors. I'm your organizer, Roshnika Fernando from NXP. Please feel free to type in your questions as you follow along, and we will answer them at the end during our Q&A session. You can type them in the right-hand panel of your GoToWebinar browser, or if you're on mobile, hit the question mark button on the top and you can type in your questions from there. If you want to learn more about designing a smart device using i.MX RT, we'll post a poll at the end of the call and you can let us know if you want a follow-up call with Matt. So without further ado, let me hand it off to our presenters, Matt and Eduardo.
Thank you, Roshnika. This is Eduardo Montanez. Thank you, everyone, for attending our webinar. I'm with NXP, Marketing Manager for our IoT Edge Processing microcontrollers today, specifically focused on the i.MX RT and these smart devices. I'm going to hand it over to Matt, who's going to start our material today, and then I'll come in the back of the presentation to share more information on the i.MX RT.
Yeah, thank you, Eduardo. This is Matt Wasson. My background is that I was in white goods for about 10 years, mostly designing top-load washing machines and capacitive user interfaces. After that, I did some thermostats and water heaters and air control over at a heating and air company. So that's kind of my background, and so that's kind of why we're here, is that doing a lot of projects with a lot of high volume. We're always having to have a cost, an eye on cost. A lot of these projects I've done have been over in the 3 million units a year, and with that, you have to kind of rationalize everything you put on the board, and that's why I really love this i.MX RT. They have done a great job at having a huge amount of performance and a cost that's very low. And so, in my opinion, this platform is really the best value that's out on the market. And during this conversation, I'd really like you to think about some of the pressure points that you have. If that's, RAM, if you're having limitations on your RAM, processing speed, you really need some DSP-like capabilities or the floating point unit. Just have that in mind as we're going through, and maybe we can help with some of those issues that you have with this platform. So kind of what we're going to do going over this whole overview is that we're going to show you some of the trends that we're seeing in the smart devices, where the RT fits in this, this kind of smart home device space. And after that, we're going to show you kind of methods that we think that you can really show a difference in your products and how you can start getting more out of the data that you may already have in your system. After that, we're going to just do the overview portfolio and some of the ecosystem that comes along with the RT, and some of that also shows where NXP is going off and what direction they're going off, and showing how they're supporting you in your efforts. So some growing trends we have is that increased performance and memory needs, to keep up with your features, and really doing some of that. We all know that you never can have enough speed to do things, but whenever I was kind of looking at this and putting this together, some of the issues that I've seen in my past has been, RAM utilization, and so people have always been doing more code modularity and trying to reuse more code, and that's always come into some issues that we've had, where we've started to run out of RAM and needing to buy higher and higher flash sizes just really to bump up the RAM sizes. And so here I'd like you to focus on some of that, because realistically we're talking about starting the microcontrollers at 120K of RAM and getting all the way up to that 2 meg. And just for an asterisk, a lot of times I mess up and I say 128K of flash, but that's actually RAM, so that's on-chip RAM. Real-time control, we're always asked to do more features, better features. And here I'm just trying to show that, realistically we can get a lot of stuff out of the data that we have. We can, process things a little bit more cleanly without having to jump through the hoops of whenever you have an 8-bit micro, or even an M0 sometimes running at 40 or 60 megahertz isn't really going to give you enough time to do some of the FFTs and some of that stuff that you want. So Also smart home, smartphone like HMIs. I don't know if anybody here's had to have marketing come to you and say, hey, I really want you to have this iPhone up on, your thermostat or on your refrigerator, but that can get pretty tense. And the nice thing here is that we're not talking about a whole lot of costs, and having some of the capabilities that run HMIs really cleanly is really nice. And later on in this presentation, we'll also talk about the voice and audio that is also coming along with the i.MX platform. AI, ML, again, NXP's, really paving a road of getting you to having AI and ML kind of capabilities in some of these microcontrollers. And the nice thing is that these products will have a ton of processing for you today, and then they can also come and help out, the AI ML later on in your development whenever you want to start taking it and actually, implementing a brain kind of into your devices and having it try to make decisions on its own instead of just all things that are pre-programmed. So enhanced security, this is really neat because in NXP in general really has a rigorous security measures, and from secure boot, software integrity, handling all the secure keys, and we'll cover some more of that later on. This is kind of some of the landscape that we're seeing, in the smart home, I'd say arena. The cool thing here, and I'm apologize, my history is all in white goods. Most of my history is in white goods, so I like to talk about them. But the thing that I think is really awesome here is that, you have the low end of the 1010 all the way to the 1170. And from that, you can actually do things that, you could make a blender, and you could have, a dollar micro doing that blender, but in the same architecture, in the same platform, and you're not doing, you don't have a bunch of vendors, a bunch of different tools. You can have that HMI display that looks like the smartphone that's also controlling the motor down below. And so I know I picked on white goods, but the breadth of products that you can support with this family is kind of overwhelming. So I was just kind of try to point some of that out. Real-time control. This is something that I really like. I think this is really cool. And so I think as appliances get smarter, designers are going to have to be tasked to find ways to improve their products by looking at data that's in their systems. And I was going to bring up a bunch of things that I think we already know, but like even on refrigerators, right? The NTCs, in my past, we've always talked about slowing down the NTC response so that, we don't have to, process, we won't see some of the overshoots and stuff like that. But realistically, in my mind, I wonder what kind of data we're throwing away. So if you actually had a faster NTC and you could see some of that, whenever somebody opens the door and shoves in a pizza box or something, maybe you can adjust the control so that you actually can get more air, below that pizza box, or even throw an error that, hey, we saw the door open, we saw the pizza box go in, we shut the door, we saw the airflow. We saw, the instantaneous change up above the pizza box, but below we didn't see anything. So my thought is like here, where we start having all this power, why not remove some of that and have faster NTC, see more data, and let the processor slow it down for the decisions of, what's the temperature inside overall, but maybe having more ability to, make decisions that help you with having a consistent temperature across the whole refrigerator. So thermostats, again, it's a sensor integration. It's kind of the name of the game, I think, in thermostats right now, is that you have all these different controls throughout your house. So you have like an air handler, and you have your outdoor unit and your furnace and stuff, and all of these things start having motor controls, so they're all variable speed. And so you're taking all of this data and you're trying to make the best decisions on running all these motors at 78%, and you're trying to run the compressor at something, and really you're trying to squeeze all that data and make the best decisions to help you with your energy. And you could even find potential problems with some of this thing. So if you start seeing that you're running your compressor really heavily and the outside temperature is not too high, some of these prognostic stuffs might be a little bit more interesting. On the metering side, this actually really surprised me when I started digging into it, is that meters, they actually look out to like the 50th harmonic, and you have to recreate that 50th harmonic. And so being able to take a bunch of, A to Ds, process all of that, and then, try to recreate some of these harmonics in a very nice fashion between the voltage and current, and maybe on multiple legs, that's where I think the RT platform really is. It has a huge advantage being, you know, one of the fastest MCUs on the market. Factory automation. I kind of look this a little bit like thermostats, where there's a bunch of data that we can be taking from different realms, right? So you could have sound, you could have light, you could have vibration, and start making better decisions based off all the sensor integration. Sometimes sensor fusion, what people call it, but that term's overused in my mind. So this is kind of where my passion lies. Is I've had to do a bunch of current and voltage measurements and power measurements and clean up after people. So really, you know, a lot of people today look at the peak of this, and then they'll, you know, they'll sample their A to Ds. They'll look at the peak, and then they'll kind of come up with a swag on what the current actually is. But sample this thing. So if you have this microcontroller so fast, sample this, get real data, be able to recreate this and, you know, kind of in your software. And I fully believe that, like with pumps and stuff, you'll be able to find, you know, stalled motors, locked rotors. The magnitude of the current may tell you when they're the motor's aging or bearings going bad. On pumps, it's kind of interesting. I was thinking back in my history, and we have done some current sensing, not to this scale that I wish I could have, but like in say a washing machine, when you're sitting there and you're pumping this liquid out of the bottom of a washing machine, what happens is that you pull all that liquid out and you kind of try to push it up through a hose, and then it comes back down. And so what ends up happening is that you have this gargling that goes on behind the washing machine. It sounds like you have a dead animal back there. And but what I'm saying is that you can see that in your current. So you can sit there and watch when you have a load, and then whenever the current drops quickly, you can just shut that off and kill, you know, kill, that's the wrong term, but you could actually stop that gargling so that, you know, your customer is not thinking there's something wrong with your machine. You know, you can actually speed up your cycle. You can do a bunch of things by taking out the time. Before, what we normally do is that we just set a timer and say, hey, once we see the pressure get below X, gargle for 25 seconds, and that's just not needed when you have a really good measurement system. Same way, pumps, I've actually seen where you have issues with pumps, and so you have, we had a pump that was copper winding and we went to aluminum winding, and the thing started overheating. And so what happened is that you started shorting between different windings. And then what happens is that your current goes up, your, you know, the power in the pump goes up, you start shorting windings faster, you have a really bad issue coming up. And so having these currents, you could actually set limits on all of your loads, and you could, you know, say if the current goes above X, it should never happen. So shut down, you know, not only that, but you can tell your service guy, hey, you have an issue, come fix the pump. And everybody looks like a hero. You look like a hero with your product. The service guy looks like a hero. Uptime's, you know, higher. Everybody gets happy about that. So water valves, again, similar, you know, being on the white goods, we had water valves that would stick, and it would be really easy. If you look at the picture, the same way is that water valve would have a high inrush and then drop down. Problem is that, you know, after hundreds of thousands of cycles and those things, and the, you know, some of the places, kind of like mine in Indiana, my water's really bad. It can get stuck, and so what happens is it takes a while for the thing to drop. So anyhow, what you can sit there and do is watch that current profile, and you can actually tell when you have issues or if your valve's opening or not. Heaters, same way. And sometimes these things are a little bit tricky. So like, I mean, you can see if a heater's on, heater's off, but what if you could see a heater without water? Or if you could see that you had an issue with the insulation around your heater, so that you were actually, you know, conducting a little bit through the water through your chassis, which is earth grounded. And maybe you could see these issues if you were measuring current and you had a very accurate measurement system, and not throwing anything away. Starting caps is another one that has a lot of issues. Starting caps, I think, are pretty interesting because you could turn around and you could, you know, not only measure the amplitude, but maybe you could look at the phase compared to voltage and actually come up with an algorithm that says, you know, hey, with this amplitude and how long it stays high and comes down low, and then maybe with the phase shift, you could almost tell somebody what the capacitance is and how it starts to reduce in your system, and go from there and be able to, again, service call, super easy. Even before a service call happens, on this case, you could just say, hey, your capacitance is really low. Please consider changing your service, your starting cap. So this is what happens when you give an engineer some idea of, you know, control over this. Is please do not measure the RMS when you're using this for sensing. I've spent, you know, months, if not year of my life, looking at voltage and current sensing and at actually multiple companies. And what ends up being is that somebody has either taken the peak and said it was perfect and tried to use that, or they have made this into a DC value by filtering it a lot, and they miss the point, right? And so here, all I'm saying that is if you look at this with the control thinks value, that's actually RMS, and then you multiply it up. So all of these, you can see that the RMS is fairly similar. I probably could have made them all 120, but I was in Excel, and so I was a little bit lazy. But you can also see where the control thinks. So these waveforms, I will tell you, are in the US. You will see these. Maybe the phase is a little bit off because I made the phases the worst case, but you will see that a very high, 15% of the third harmonic. You will see that in your system. So if you're in the US, I would plan for something like this. But if you have, if you're sampling this enough, you'll be able to see this. Your RMS will come out. You won't have to worry about the wave shape as much. And I would say if you're launching this worldwide, I would plan on even worse wave shapes than this. Again, this slide kind of came out a little bit funny, but so the out of balance routines and stuff like this, I think this would be something that would not only help have better algorithms, but really take time out of the algorithm development time. And so what a lot of people have done is that they bound the system so small, and then they try to figure out a way to see out of balances. If that's like a projection of acceleration and you're counting things above or below the line, this way you sit there and you see your fundamental frequency you're running at, and then you would see these harmonics, and you could trigger off of a magnitude of that harmonic, and you don't even have to worry about trying to come up with algorithms that only work for a subset of the whole, everything out in the market. And so I really think that bearings, lost magnets, bent blades, all these things that you can find using FFTs and stuff that historically, at least in my view, we haven't been able to do in appliances because we use very low-end micros. But that's where we're coming in at with NXP, is that realistically, I mean, you're talking about $1. And so there's been times in high volume appliances that have gone way over $1 and not even came close to the speed that we have here. So don't really limit this just to current, just because my mind only allows current and speeds and stuff. But realistically, I mean, maybe this is a microphone that's looking way out, frequencies much higher than we can even hear, and you're hearing something in your system that would help you have a better, algorithm or user experience. So to touch a little bit more on the HMIs, the cool thing about HMIs is that, at least with the RT series, is that there's a ton of hardware flexibility, and there's a lot of interfaces that it can actually speak about, and we'll go over that with some of the overview. But the other nice thing is that we've talked a little bit about the RAM already, and so we talked about, we start at 128K. And move all the way up to 2 meg. And so having multiple screens in your buffer, being able to flip those back, on and off, graphics accelerations, and something that I've heard people complain a little bit about here is that, hey, the RT needs to have external flash, but realistically, I don't see that as a downside. I mean, yeah, you got to put 2 things down on your board, but the cool thing here is that all these HMIs need external flash almost, unless you're spending a lot of money. And so you're already buying that external flash. Why pay for the internal flash? But the other thing is it allows the i.MX RT, it allows for them to be at the process that is most cost effective. It also allows for the memory to be at a very cost effective process. And so it allows everybody to run as fast as they can, not having to wait on the memory or vice versa. So it allows everybody to kind of do their job the best. And so you're letting, NXP do what they do best, and you're letting the memory supplier do what they do best. The other thing I think is really cool for a hardware guy is that if you change what screens you need, the RT is going to be able to do that, and really you're just dropping in a new quad SPI flash for a larger amount of flash. So I think that's pretty cool. All right, so this may or may not be real, but so Bill Gates might have said this, but I don't know. Anyway, he talks about 640K is more than you'll ever need. It may or may not be real, but really what I wanted to point out is that let's just think about your application. What would take you guys to have, a better application, better algorithms? What would help your customer really? And is that, a floating point unit so that your math is, more precise, or is that a M7 that can run up to gigahertz, and maybe that's getting rid of the DSP and the micro, or maybe that's running an HMI and a motor control. Beyond chip RAM being a huge thing. We've talked about that a couple of times, and really, this is why I really love this thing, is the value that we have, $1 for, the 1010. So with that, I am going to pass this over to Eduardo, and hopefully it's all seamless.
All right. Thank you, Matt. I appreciate that. Can you guys hear me okay? You hear me all right?
I can hear you.
Perfect. Thank you. Man, I love talking to engineers like Matt. I think being able to dream about your current application and where you can take it in the future is absolutely an engineer's dream. But having a product line like the i.MX RT that gives you very extensive amount of features to not only execute your current product, but know that it's going to give you enough headroom moving forward as you get more and more requirements in your system, is really what excites us at NXP, is being able to do more and more. Just to give you a little bit of my background, I've been in the embedded microcontroller industry now for 20 years. Started really as a support engineer, doing applications engineering, learning about customer challenges and problems and helping them solve them. But then moving more into an architecture role, defining products, everything from clock trees, pinouts, periphery, then running that team. So really a heavy technical background, and it's talking to engineers like Matt and yourselves that really drive our passion for making the best MCUs we can. And now, obviously, from a product management perspective and working with customers to make sure that their system level evaluation and overview are managed by not only the RT, but other NXP components in order to make sure that we're satisfying the requirements of the entire system. So those kind of examples really help in discussions with you. The customers really help us make better products down in the future. So today I'm going to give you an overview on the i.MX RT and where we're taking the portfolio, talking about some of those growing trends. Here what I'm showing is where the RT fits in the NXP edge processing continuum. So as you can see, we have products for very, very low-end, low-cost MCUs with embedded flash, all the way to networking products. The i.MX RTs that bridge between the MCU and the MPU world. Since we have expertise in both of these spaces, we decided to fill a gap in the industry by making these crossover microcontrollers. So we take the high performance of an application processor like our i.MX products with Cortex-A class devices running up to 2 gigahertz with very rich HMI experiences, and we combine that with our microcontroller background with Cortex-M cores running up to 300 megahertz with embedded memory and with real-time deterministic support and tool chains. So that's the RT. But what we're doing now is expanding that portfolio, now supporting both the Cortex-M33 and the Cortex-M7 cores in the RT crossover microcontroller series, but pushing the boundaries now with the RT1170 with up to 1 gigahertz Cortex-M7 performance, which is unheard of. We're also now, as we look at some of these trends where you're starting to do more AI, more machine learning, richer HMI experiences with audio and voice processing, we're now adding more and more accelerators. So it goes beyond just the main core of the device, but adding a GPU, adding a DSP, and adding other math accelerators to help perform some of those functions in the system, therefore making them smarter. So let's go through some of the key highlights, and I'll try to give you nuggets of information on how these functions are applicable to making your device even smarter. So first is the performance. So obviously having that headroom to add more and more functionality and not limit your product today or tomorrow by giving you a product that can outperform anyone in the market with a 1 gigahertz MCU. And then we have another blend of products now with our Cortex-M33 lineup running up to 300 megahertz, where it's not just about performance, but very energy efficient performance. Adding a 600 megahertz DSP now with the Hi-Fi 4 DSP from Cadence to sit alongside a Cortex-M33 in our RT600 and RT500 products is another way for us to not only be more energy efficient, allow you to do the ML AI type functions and audio voice processing, but also to be very energy efficient. Like Matt mentioned, these products are flashless, but we do have variants that we have done embedded SIP flash. So we take a serial quad flash from one of our vendors and we put it in the same package as an i.MX RT product that's very high performance. But we also have a very scalable level of memory, starting from products with 128K of on-chip SRAM going all the way to 5 megabytes of on-chip SRAM. From an integration perspective, we don't skimp on security. So having dedicated crypto engines that have the ability for high assurance boot, authentication, your code and data. And since these are flashless, we have a very rich quad SPI, octal SPI interface that allows the interfacing to serial NOR, serial NAND, and some of the serial low pin count SRAMs out there as well. To make that part of the system even more secure, we do have on-the-fly quad SPI flash or external bus decryption. Okay, so you can keep all your code and data secure, encrypted in that external memory. For the HMI experience, we make it simpler by enabling, and I'll talk about some of the enablement before this webinar of our GPU. So we have products with acceleration and full-blown GPUs with interfaces to either parallel, whether it's an 8080 RGB or a MIPI display interface. We also have products with camera interfaces as well. If you're trying to do facial recognition, gesture recognition, we have software to help you do that with our EIQ platform. From a display controller perspective, I think one point that Matt made that I really love to kind of focus on is the ability to control different size displays. So you can see here that we have up to wide XVGA support with those products with graphics. But I think one of the pieces I like to focus on is the flexibility of the RT platform, as you can scale with products with low resolution screens that only use the on-chip SRAM, but then be able to easily add an external either low pin count PSRAM or an SDRAM to allow you to easily grow a different product line in your portfolio with a larger high resolution display. From a voice and audio processing perspective, we now have started to add into the portfolio digital microphone interface, and also all these products have several I2S interfaces. From an industrial control perspective, we have numerous Ethernet controllers across the portfolio. We have 10100 control, and then we have gigabit as well. And we also have several CAN interfaces with FD support. And the overall message is that you get all this functionality at a very low BOM cost. So we start with the RT1010 at 99 cents for 100K resale, but it's not just about the bottom line, how inexpensive can you get this microcontroller, but how inexpensive is the system around it. So we fully integrate the PMIC with DC-DC, so no need for an external PMIC like you would in an application processor. There's also very low cost packages, whether it's a 4-layer PCB design with our BGAs or a 2-layer designed with our LQFPs. We do have some products that add the SDRAM interface if you need even more external RAM. And overall, the ease of use is that of a microcontroller. You'll have the same tool chain and enablement that you would have in an embedded flash microcontroller like our LPC and our Kinetis lineup. So let's talk about some of the history of first with the RT. The RT really has only been in the market now for about 3 years, but we've had many successes in the market with the product because it really did fit a very unique profile and gap that was in the industry. First, in 2017, we introduced the RT1050, which was the first crossover microcontroller supporting 600 megahertz Cortex-M7. Since then, we have grown in features, memory, and other functionalities. So we have the RT1060 with 1 megabyte on-chip SRAM. We have created some SIP options with the RT1064 that has a 4 megabyte quad flash in the system in package. We have since then, in late 2018, announced the first 28 nanometer FDSOI crossover MCU with the RT600. That was our first play into the Cortex-M33 with a Hi-Fi 4 DSP sitting alongside for high performance ML, AI, audio and voice processing. We've also in 2019 introduced some lower cost solutions for the RT series, lower cost LQFP packages with the RT1015, 1020, and then the lowest cost crossover MCU in the RT1010 with a sub-$1 MCU. And by the end of this year, we will launch the first gigahertz MCU in the RT1170, which has a dual core option. So you could either run the Cortex-M7 up to gigahertz and the coprocessor Cortex-M4 up to 400 megahertz. We've also started to build application solutions around the RT family. We have 3 different products from our solutions team, which is the RT106A, which is the first AVS certified solution for cloud-based voice control. Then we have the RT106F, which adds it's a turnkey solution for face and expression recognition. And then we have the RT106L, which is far field local voice control. I've already spoken to the RT series using the 2 highest performance Cortex-M cores from ARM. So you can see the Cortex-M33 is the evolution of the Cortex-M4, and the Cortex-M7 is the highest performance ARM Cortex-M core in the market. Here's an overview of the portfolio, so you can see how inexpensive point of entry is for the i.MX RT series, starting with the RT1010. But then moving up from a functionality perspective, the way that this chart reads is that we have the products with at the entry point with 500 megahertz Cortex-M7. So we don't skimp on performance. You just have different variants of memory with the RT1010 starting at 128K, moving up to the RT1020 with 256K of on-chip SRAM, the RT1050 with half a meg of on-chip SRAM, the RT1060 with 1 meg of on-chip SRAM. And note that the RT1050 is where we start to introduce graphics, RT1064 with a SIP option with a 4 megabyte flash. And then soon we will have in production the 1 gigahertz Cortex-M7 and the RT1170. Here in green, you'll notice the Cortex-M33 portfolio, where we have focused not only on performance, but energy efficiency and additional integration of DSP with a Cadence Hi-Fi 4 DSP in order to, excuse me, in order to accelerate some of that voice and audio processing. I'll talk about some of these product highlights here shortly. So the key message here is scalability, right? You get a little bit of everything, and we have a product that can help your portfolio in the very low end, like Matt mentioned, with entry-level appliance, all the way to the high-end appliance or smart device that adds HMI and higher performance capabilities. So you have the RT1010, 1015, and 1020 at that entry point with LQFP packages, but still packing a lot of punch with 500 megahertz. Then moving up into our introduction into the graphics space and more external memory options with the RT1050, 1060, 1064. And those products there are all now in production and have been for some time, so they are very mature. Then we're getting ready to launch the RT1170, which adds even more security, advanced security, but also adds even more performance and memory, okay? And has a 2D GPU added, so your graphics go up to another level. And then we have already introduced and in production now the RT600 that came out in February, and that's our Cortex-M33 and the RT series that adds trust zone. That's part of the V8M instruction set architecture that ARM introduced last year. And this product also adds the Cadence in Silica Hi-Fi 4 DSP that can run up to 600 megahertz. That's a lot of DSP performance. It can help you displace not only the controlling MCU in a system, but also the DSP that sits alongside of it. We have added 4.5 megabytes of on-chip SRAM into this product to really allow you to manage all that data that's coming in, whether it's sensor data, whether it's audio, voice, and be able to have enough compute to have very advanced audio integration in this device. So let's go through some of the key differentiations of each individual product highlight here. The RT1010, obviously that breaks the dollar barrier, and it's the entry point into the RT series. It's a very low cost MCU with a high level of performance and integration. So 99 cents for volume production, up to 500 megahertz Cortex-M7, 128K of on-chip SRAM, all that's tightly coupled memory, meaning it's zero weight state. It still has high-speed USB, both host and device support, I2S, Flex PWM. So one thing to note here is that all these RT devices have a very sophisticated amount of set of timers to help with motor control. So if your applications have motor control or power conversion type of functionality, then you can get that even in the lowest entry point of the RT series. All these products have the on-the-fly AES decryption, again for that serial flash hanging side by side to the RT product. Okay, so you make sure that the entire system is secure. And here's the block diagram of the RT1010. We have both industrial and consumer temperature options here, and this product comes in an 80 LQFP 12 by 12 package. So this is a leaded QFP, so very simple to design in a 2-layer PCB. So that was the entry point of the RT series. Now I want to talk about the other end of the spectrum. You have the RT1170, which is, I would say, the superset of the product line. And note that you'll have everything in between with the 1015, 1020, 1050, 1060, 1064. This RT1170 really differentiates because of its high performance with the first gigahertz Cortex-M7 and a dual core option with a 400 megahertz Cortex-M4. We have further enhanced the security in this device. One particular function I like to talk about is the ability to do tamper detection. That's something that we added on the RT1170. So be able to see if someone's trying to get into your system, perhaps to get access to your IP, your software, or just learn more about your product. You can do a tamper detection of the product, whether there's voltage skews, temperature skews, and be able to wipe keys, erase keys from the product. This product will introduce 2 megabytes of on-chip SRAM, a high-speed ADC, 1 megasample per second, a DAC, and gigabit Ethernet, one with time-sensitive networking and one with AVS. This has a 2D GPU and a MIPI camera and display. And we are moving the portfolio, the RT portfolio, to more advanced technology nodes like 28 nanometer FD-SOI to not only get the highest performance we can get out of these products, but also to optimize the active and leakage power of these devices. Here's the RT1170. Obviously, with more functionality, this will require a larger package as well. So we have 289 map VGA and a 14 by 14 0.8 millimeter pitch. This will be the first RT that will be automotive qualified, so we will support consumer, industrial, and automotive temp with minus 40 to 125 degrees C. Again, I talked about the dual core option. From a graphics perspective, the 2D GPU, a lot of RAM, camera, ST-RAM controller that can operate up to 200 megahertz. We will have two FlexPhy interfaces. That's the low pin count serial interface to external NOR, NAND, or RAM. Okay. Two eMMC SDIO interfaces. I see a lot of customers want to use that, perhaps one for Wi-Fi and another one for eMMC. We have two USB 2 controllers with the integrated PHY for high speed and full speed support. A lot of audio functions with the I2S, SpeedIF, ASRC, and digital microphone input. Three Ethernet controllers, gigabit for two of them, and 10100 for the third. Two 12-bit ADCs with 2 megasamples per second, a lot of input channels, 4 analog comparators, fully integrated PMU with DC-DC and LDOs, and again, the very sophisticated advanced security. Here's just a system overview to show some of the things that you can do with this device. So obviously, plenty of interfaces for speakers, for high-speed wired communications, for display, for camera, for memory interfaces, whether it's NOR, NAND, SD-RAM, SD card. We are with the type of performance you get out of this device. Obviously, it's very good for audio applications, image, and voice recognition as well. We have sophisticated timers here for advanced motor control. We have done demonstrations on the RT, and this is not just specific to the RT1170, but we've done it on the RT1050 of being able to drive four motors plus have HMI all running on the same device. Okay. Plenty of communication interfaces for sensing and other communication protocols and so forth. So there's a lot of functionality, and again, this superset of the RT series, and you'll have a lot of this functionality across the portfolio. So let's talk about a different type of device, a very segment-specific device. One of my particular areas of focus at NXP is the wearables and personal devices. So we've talked a lot so far about appliances, thermostats. Obviously, smart devices could be anything that has a very rich functionality. The RT600 is a product that is seeing a lot of success in the smart devices like headphones, hearables, game controllers, sensor hubs, and the list goes on, right? And we have variants of this product that will be very even better power consumption and will be used in a lot of smart watches as well. So the capability really across the portfolio is really limitless. What we have here is Cortex-M33 that runs up to 300 megahertz, but has side by side a Cadence Tensilica Hi-Fi 4 DSP that runs up to 600 megahertz. That's just a lot of performance packed into a DSP. So it really kind of opens up a lot of new markets for us. The quad 32 by 32 MAC is really the key there. This will have all the MCU functions that you're accustomed to in an MCU, many that I've already talked to. Obviously, this product has a lot of memory, 4.5 megabytes on chip SRAM, all that are zero weight state, meaning you will have zero cycle, that means zero weight state access to this entire on-chip SRAM for code and data, okay? From an integration perspective, you have a lot of comms interfaces, you have high-speed USB, you still have the quad octal SPI interface for flash or PSRAM, and you have two SD-eMMC interfaces. You have a digital microphone interface, obviously for the audio and voice applications, and we continue to have similar advanced security that we've spoken to on the other RT products. Here's the block diagram. The one thing that I want to highlight for this product is that it's a consumer temperature only product, so -20 to 70 degrees C, but you can see some of the target applications here that we're seeing a lot of success because of the combination of MCU periphery plus the Cortex-M33 and the high performance DSP. Just to show how much more performance you get by having a Hi-Fi 4 DSP versus just a traditional Cortex-M doing the DSP calculations. Here's an example of FFT computation on the Cortex-M33 on an IP that we have on this product called PowerQuad, which is a math accelerator, and then on the Hi-Fi 4 DSP. So if you look at the far left, if you take, for example, just the CMSys DSP library is running on the Cortex-M33, and then you look at how much more performance you get out of the Hi-Fi 4 DSP versus the Cortex-M33 on the far right, it could be anywhere from 8 to 26 times higher performance for FFT execution because you have a true DSP integrated into this microcontroller. So last but not least is let's touch on the enablement, and then we'll open to Q&A. So you will get the breadth of the NXP enablement in the RT series, whether it's FreeRTOS, whether it's Zephyr. From a graphics perspective, I'll talk to that in the next few slides. We will provide our MCUXpresso ecosystem that provides the IDE, SDK, configuration tools to get you started very quickly. We have an EVK for all of these products that really allow you to do power measurements and to use many of the interfaces that I've spoken to. So the enablement is quite rich. Here's a slide on the MCUXpresso ecosystem. So the IDE that we carry across our MCUs, so it'll be very familiar to you regardless of whether you're using LPC, Kinetis, or i.MX RT. The SDK that will provide drivers and many software examples to get you started very quickly, configuration tools to set up your pins, configurations, your clock configurations in a graphical way, and even the peripherals as well. We've just recently introduced a tool that we're continuing to build out for secure provisioning. So being able to program fuses, being able to encrypt an image that you're gonna program into the device as well, and many other security functions. Obviously, we'll continue to support and work with our partner IDEs, IAR and Kyle, and many debug probes out there as well. We will, for our new RT devices with DSP, we will and have provide libraries and codecs that we've licensed for our end customers. So you have an Extens Audio Framework, Nature DSP library, many codecs as you see listed here that can be used by our customers royalty-free. We do have a Cadence Tensilica toolchain as well if you need to develop software to run on the Hi-Fi 4 DSP. So to wrap up, I'm going to talk about some HMI solutions on the i.MX RT. We have many graphics partners and some development ongoing internally for graphics. So obviously the RT being very rich in graphics with many display capabilities. We have partner solutions from Crank, Embedded Wizard, doing open source little VGL development, and our complementary Sega M1 solution as well. From a voice perspective, we're developing internal NXP voice intelligent technology for local far field control. This uses a text to model technology. So it will allow you to quickly develop many commands and varied commands for your end application. We have that running on the RT1060 today, and we're starting to support more and more RT products. We also have partners that do wake word engines at a very low power, like Sensory and Retune for voice. From an audio perspective, NXP has also developed new technology called Essential Audio Processing. This will allow you to use the RT in an audio playback application where you could introduce these free libraries for bass enhancement, treble enhancement, loudness maximizer, and we will have a tuning tool for a lot of these functionalities so you can have a richer audio playback experience. Obviously, from an audio perspective, if you need to do things like acoustic echo cancellation, wind reduction, or other AFE type functions, we have support on our i.MX RT for partners like DSP Concepts and Alongo that are developing not only for the Cortex-M cores, but also for the Hi-Fi 4 DSP that I showed in the RT600. So overall, this is really just to give you kind of a high-level picture of not only what we're doing in the MCUs across the i.MX RT series, but what we're doing to help you make better smart devices. So I'm going to wrap it up here so we can have enough time for Q&A. I appreciate everyone's attention today, and I'm looking forward to your questions.
All right, thank you so much, Matt and Eduardo. We're going to move over to the Q&A session, but first I'm going to pull up a little poll for you guys. This gives you an opportunity, if you like, to schedule a follow-up call with Matt if you're interested in learning a little bit more, talking about your design and getting some more guidance. Matt obviously has a ton of experience in creating smart devices, so he's an incredibly valuable resource for you. So I'll leave this poll up for a minute and get started on some of the questions that we have in the Q&A. Just a reminder for all the folks on the call, you still have time to add in some questions. So without further ado, let me move over to the question. Okay, first, Matt, thanks for the explanation. Do you have a benchmark about using i.MX RT for audio processing like voice over IP?
I don't. Eduardo, do you have something that would have audio?
Yeah, absolutely. So we have done plenty of audio processing, both on the Cortex-M7 RTs, the RT1000s, and also now with a Hi-Fi 4 DSP on the RT600s. From a benchmark perspective, so we have plenty of customer testimonials and work ongoing there. I guess the first part of the question, as far as benchmarks, I don't have any off the top of my head, but potentially we can, as part of this webinar, is to have an opportunity to have a further discussion, understand more about what you're trying to do. Are you looking for benchmarking on power, on performance? We have a lot of information, additional information we can share with you related to audio processing on these products.
That's a good opportunity to pick your brain if you do a follow-up call with him. Next question. Is there additional external RAM or flash needed to realize a SPI to Ethernet application for sensor data? For example, on the RT1020.
It really depends. If I can, I'll address this first, but it really depends on the amount of data that you need to manage, right? So RT1020 has 256K of on-chip SRAM, right? So the serial flash is a must-have, right? You have to, unless you have an application processor in the system that can pre-program the RT, use some of the RAM for execution. But I'm guessing that for this system, you're most likely going to use some type of serial NOR on the Flex SPI, which is going to do execute in place, meaning you're going to leverage our cache controller and our cache for the Cortex-M7 to have a high performance execution of your code. And you're going to use the 256K on-chip SRAM as your buffer space for moving the data. Now, I think you said Ethernet, so I think you might be better off looking at the 1050. So you have the 10100 as a bridge, right? Because you're using this product as a bridge. So then you'd have a little bit more on-chip SRAM, in that case 512K on-chip SRAM to give you even more additional buffer space. But again, it really depends on how much data you need to buffer to sustain the throughput that you need for your application.
Fantastic. Are there any i.MX RT devices that can support Linux?
So these are real-time operating system devices, so not Linux. Now, I've seen customers run across many MCUs, micro C Linux or Linux for MCUs or something like it. I know I've been getting a lot of interest for some customers coming from the Linux world on Zephyr operating system, so maybe that's something to consider as well.
Realistic, once you go to Linux, you'd be better set probably in the i.MX, like the 7 ULP or the 8M. You'd be in a different platform probably.
Yeah, that's correct. I mean, we have plenty of application processors able to run Linux, and sometimes your ecosystem or the other components in your system would push you towards Linux because they have better support for those external components. So if that is the case, then we have other products in the NXP edge processing portfolio that might be a better suit.
Great. Do you have a reprogrammable smartwatch, maybe a reference design we can use for i.MX RT?
From a smartwatch perspective, I think a lot of the components that you would expect in the system, which would be potentially a lot of external memory for data logging, the capability to do a display, and also the ability to have connectivity, whether that's BLE or Wi-Fi. A lot of that can be realized right off the bat for your evaluation on our EVKs. So if you take one of our EVKs, for example, and I'll talk to the RT600, since that's one of the products that we're seeing in a lot of the personal devices and wearable space, you'll have on there an AP memory serial PSRAM, so tons of additional SRAM if you need more for data processing or for graphics buffers. You have well, in this case, not graphics buffers, because it would be a follow-on product, the RT500 with the display capabilities. But then you have an accelerometer, which is very typical in a smartwatch as well. You'd have a PMIC running that device, which is very typical of a smartwatch as well. You'd have an M.2 connector for being able to take a Wi-Fi or a combo BLE module and plug into that. And then we provide a lot of drivers in our SDK to kind of help you bridge all those pieces and bring them together for a smart watch or personal device application.
All right, we have a couple more questions, but we are out of time. I'm going to throw one last one, and it's actually a combination. When can customers get the i.MX RT1170, and do they have to use an RTOS to work with it?
Yeah, that's an excellent question. So the target right now is for us to go to production with a consumer temperature RT1170 variant as early as November of this year, and then we'll from then roll out the industrial and then the automotive moving into Q1 of 2021. So work with Future, work with them to try to get you in line for evaluation of those products. I know we are already working heavily with a lot of early access customers. So depending on your opportunity, we can start engaging with you maybe perhaps as early as September.
Wonderful. So with that, we are at the end of our webinar. Thank you so much, Matt and Eduardo, for your time and expertise. For the folks on the
Absolutely.
call,
Thank you.
Yeah, thank you guys.
Thank you. For the folks on the call, we will be posting the session's recording on NXP's training webpage and on Future Electronics' YouTube page. It will take us a couple of days to get it online. So we'll send you a reminder when it's available. We'll also have a PDF of the slide deck so you can download it. So with that, the webinar is now concluding. Thank you so much for joining.